Hi guys, these are our last set of notes for our solving polynomials unit. Your table of contents you can fill in, pause here, slide 14 and 15 is graphing polynomials. We'll turn our notebooks in on Friday. You need a piece of paper. If you printed out the PDF, that's fine, but you can just use a piece of paper and everything that's written in black, and then whatever I write down, you'll just add in. So notes 2A.3.1 is graphing polynomials. That's the title for your notes. You don't have to write down the essential question, but basically what did the leading coefficient and degree of the polynomial tell you about the graph of the polynomial? And then you do have to write down everything that's in black, So sketch a graph using, and then the max number of real roots. Remember, your roots are just your x-intercepts. So your maximum number of real roots is just going to be the same number as the degree. So if you have a degree cubic, x cubed, then the most roots you can have, the most x-intercepts you can have is 3. If it's an x to the power of 7, then it's possible you have 7 x-intercepts. The maximum number of turning points, that's basically like the curves in your graph, is just 1 less than the degree. And the last thing we're going to talk about is the end behavior, like what happens at the end of your graph, okay? So basically your graph goes on forever. So what's happening as the arrows go on forever? You have arrows at the end, like which direction are they basically pointing? But end behavior is just the behavior of the graph as it approaches positive and negative infinity. As end behavior, or the behavior of the graph as x approaches positive and negative infinity. So we're basically looking at, are the arrows pointing up and down? Okay, so how we tell the end behavior, okay, you use the degree and leading coefficient. So what we want to know about the degree is we want to know, is the degree even or is the degree odd? So, is it an x to the power of an even number for your degree, or is it an x to the power of an odd number? You might want to pause and write down this little table real quick. And then, is the leading coefficient positive or negative, like ax to the power of something, or is it negative ax to the power of something? Is your leading coefficient positive or negative? That's what we care about. So what you're going to use is those facts to decide on your end behavior. What's going to happen at the end of your graph? So if it's an even degree, what you need to know is that your arrows on both the left and right hand side are both going to be pointing up if it's a positive, and they're both going to be pointing down if it's a negative. So an even degree means both arrows are going to be pointing the same direction. If that is positive, then both arrows are pointing up. If it's negative, both arrows are pointing down. If it is an odd degree, your arrows are going to be pointing opposite directions. And for an odd degree, the left-hand side would be down if it's positive, and the right-hand side up would be positive, the left side arrow would be going down, the right-hand side arrow would be going up if it was a positive leading coefficient, and it would be opposite if it was a negative leading coefficient. So I left a lot of these boxes blank because we have more stuff that we need to write in them. So the way that you write end behavior is you usually write as x approaches negative infinity, y approaches, we're going to leave it blank for right now, as x approaches positive infinity, y approaches blank. So the first one, negative infinity, is the left-hand side of the graph, and then the second one, the x approaches positive infinity, is the right-hand side of the graph. So that's what we're filling in. So since both arrows are pointing up, if it's an even degree positive leading coefficient, then both of those would be positive infinities, okay? If you're talking about a negative leading coefficient, you would say as x approaches negative infinity, y approaches blank, This part just always stays the same for all 4 of them. The only thing that changes is what y approaches. So if it's a negative leading coefficient, but it was an even degree, then both of your arrows are pointing down. So for both of them, y is heading towards negative infinity because that's the direction the arrows are pointing. If it's an odd degree, then your y's are actually going to be different. So you start with as x approaches negative infinity, that's the left side of the graph, y approaches blank, and then as x approaches positive infinity, y approaches blank, that's the right hand side of the graph. So on the left hand side of the graph, your arrow is pointing down, so it'll be negative infinity, and if it's pointing, the right hand side of the graph is pointing up, so that would be positive infinity. Last one is if you have an odd degree but negative leading coefficient, as x approaches negative infinity, y approaches blank, x approaches positive infinity, y approaches blank. So this time the left hand side of your graph is pointing up, so it's going towards positive infinity, and the right side of your graph is pointing down, so it's pointing towards negative infinity. So what you need to know is that if it's an even degree, your arrows are pointing the same direction. If it's an odd degree, your arrows are pointing opposite direction. If it's a positive leading coefficient and it's even, then they're going up. But if it's an odd degree, then it has a positive slope. If you have a negative leading coefficient and it's even, they're both pointing down. But if it's an odd degree, it has like a negative slope, you could kind of say. All right, so I believe there's 4 examples. You're going to want to grab your notebook. This is going to be one picture we take later, but your workbook, you're going to go to page 69. We have 4 examples to do. So for problem number 1, it says, this is page 69. It says determine the end behavior, maximum number of turning points, and maximum number of real roots for the function 6x to the 5th minus 3x to the 4th plus 2x plus 7. Okay, so first it says identify the leading coefficient and degree. So in order to tell that, you look at the first term, okay? The degree, what I care about it is I don't care if it's positive or negative, I just care that it is odd. And then I look at my leading coefficient and I don't care what number it is, I just care if it's positive or negative. So my degree is odd, my leading coefficient is positive. Okay, so odd degree, positive leading coefficient. For right now, we could just kind of look at our table and tell us it's an odd degree, positive leading coefficient, so this is our end behavior. We could basically just copy that down, okay? So it's an odd degree, positive leading coefficient, okay? What that means is that my arrows are pointing opposite directions, and it's going to have a positive slope, basically, to it. So here's how you write it. You write as x approaches negative infinity, that's the left side of the graph, y approaches blank, as x approaches positive infinity, that's the right hand side of the graph, y approaches blank. So if it's an odd degree, these y's are going to be opposites, and it's going to end going positive. So it's negative infinity, positive infinity, it has a positive slope. And that's all you have to do for end behavior. Then we look at the next parts of information once about the graph is the maximum number of turning points. The maximum number of turning points is 1 less than the degree. So the degree was 5. So you subtract 1 and you get 4 max turning points. So if that is the maximum, could you have less? Yes. Then we have the maximum number of real roots. This is equal to the degree. And again, it's maximum. So 5 max real roots. So it asked us for the end behavior. We found here the maximum number of turning points and the maximum number of real roots. So to tell end behavior again, you look at the degree, you care if it's even or odd. You look at the leading coefficient, you care if it's positive or negative. Then you use your little chart that we put down into our notes. It was an odd degree, positive leading coefficient, so that's the end behavior that we used. And then the maximum number of turning points and the maximum number of real roots. Real roots is equal to the degree. Maximum number of turning points is 1 less than that. All right, flip your paper over to example number 2. It says determine the end behavior of the graph, determine whether it's an even or odd, and determine the number of real roots. Okay, so to start off, in order to tell the end behavior, okay, end behavior always starts like this. As x approaches negative infinity, that's the left-hand side of the graph. Y approaches blank. And then as x approaches positive infinity, y approaches blank, that's the right-hand side of the graph. Okay, so what you have to do is you have to look at the arrows. So both of my arrows for this one are both pointing down. So what does that mean for my y? They are both heading towards negative infinity. That's my end behavior. So I could find it really easily from a graph. This red part just always stays the same no matter what. The only part that changes is that green part, and it just depends on whichever way the arrows are pointing. Then I have to decide if it's an even or odd degree. Okay, so we already did this part, describe the end behavior, we got that, determine whether it's an even or odd degree. How you decide if it's even or odd is you look at, are the arrows pointing the same direction? If the arrows are pointing the same direction, then it's even. If they're pointing opposite directions, it's odd. So since my arrows are pointing the same direction, then this is an even degree, and we'll write y just to help us. Arrows point same way. And then it asks us to determine the number of real roots. Well, the number of real roots is just however many x-intercepts you have. So we have 4 x-intercepts, so it's 4 real roots, since that is our number of x-intercepts. Okay, so we just looked at the graph. End behavior, the red part always stays the same. The only thing that changes is green. You look at which direction the arrows are pointing. You decide if it's an even or odd degree by, are the arrows pointing the same way? Even. Opposite ways would be odd. And then the number of real roots is just however many x-intercepts there are. All right, 2 more examples. This is page 71. It says use a graphing calculator to graph the function, summarize the end behavior, and turning points. Okay, so we're just going to use a little mini graph. I could, sketch the graph for us, just using the information. The fact that it's a negative even degree means that even they're going to be pointing the same way. It's negative, so that direction is going to be down. So, but they wanted us to use a graphing calculator, so we're going to go ahead and use that. So Desmos is our preferred graphing method. So I'm just going to type it in, negative x to the power of 4 plus 3x squared plus 4. So when you look at your polynomial, it kind of looks like an M shape, right? So it hits at -2 and +2. It has 3 turning points. So see how it goes up, it turns, and then it goes down, it turns and up. So it's 3 turning points, 2 x-intercepts. The end behavior, the arrows are pointing down, so it's going to help us with our end behavior, but we're going to go put that onto a little sketch of our notes. So it hit, remember, at +2 and -2 is where it hit on the graph. And then it kind of looked like an M. It went up and down like so. Okay. So it just says to summarize the end behavior and turning points. So the turning points, there it turned here, here, and here. So there was 3 turning points. So that was the maximum that it could have because it was a 4th degree polynomial, and the most you can have is 1 less. For the end behavior, remember you always start off the same. As x approaches negative infinity, y approaches blank. As x approaches positive infinity, y approaches blank. And that's the part you have to fill in based on which direction are the arrows pointing. So here, both my arrows are pointing down. So that means that they are both heading towards negative infinity. That's my end behavior. Okay, and then that last one, example 4, your page doesn't have a graph. It's just blank right there. So you, that's probably better than what I have. You guys can just draw like an X and Y axis for me. It's just a rough sketch, so it's not going to be anything crazy. It just says create a rough sketch of a graph with a 6th degree function with a 6th degree polynomial function with a positive leading coefficient. So it's going to be something like positive x to the power of 6. Okay, so it's positive leading coefficient, so it could be like 7x to the power of 6, or anything that's positive. Okay, it doesn't have to be 7, it just has to be something that's positive. All right, so what we know is if it's an even degree, okay, this is even, then we know that both arrows are going to be pointing the same direction. Since it is positive in the front, we know that it's going to be pointing up, okay? So I'm going to just draw two arrows, okay? My two arrows are going to be pointing up. I'm going to draw one on the left side of the graph and one on the right-hand side of the graph, okay? Since it is a 6-degree polynomial, that means I can have a max of 6 x-intercepts, and I can have a max of 5 turns, okay? Could you have less? Yes, okay? So I'm just going to go and I have 1 x-intercept, 2, 3, 4, 5, 6, and I connect it back up. So my graph has 1, 2, 3, 4, 5 turning points. It was the max. Yours could look totally different. I made sure I had 6 x-intercepts. You could have them go up and down as high as you want, but the how you would sketch the graph, just rough sketch, is it's an even degree, so the arrows are pointing the same direction. It's positive, leading coefficient, so that means the direction is up. The degree was 6, so that means I could have 6 x-intercepts max. I could have less, and then I could have 5 maximum number of turns, okay? All right, so here's where your notes are going to go. Slide 14, these are the notes part that we took, so that's going to go on the left. Example 1 was page 69. It's going to go on the right of slide 14. Example 2 is going to go on to that's page 70. It's going to go on the left-hand side of slide 15. And then example 3 and 4 is page 71, and that's going to go on the right-hand side of slide 15. And that is our last set of notes that we're going to have for this unit. And you guys will do your homework tonight. Thanks.